Do you know what methods geologists use to measure the age of paleolife and determine major historical events that have occurred? Will they learn about rocks and earth layers? This video walks you through how paleontologists and geologists know how old a fossil is and predict what happened in the past. The first thing we need to know is that scientists divide methods of measuring properties of an item into relative dating and absolute dating. Relative dating tells how old something is in relationship to other objects but cannot provide a year or specific date of use. In contrast, absolute dating provides a specific calendar year for its occurring. Before we get into the details of these two methods, we need to get to know someone first. His name was Charles Lyell, who was born on the 14th November, 1797 and died on the 22nd February, 1875. He proposed that the Earth has always changed in a uniform way and that the present is the key to the past. This idea is called uniformitarianism. This idea shows that whether it is mountain building or weathering and erosion, it takes a long time and proceeds slowly. So the current appearances of Earth's crust is not created by a momentary change, but under a very gradual process even today. Uniformitarianism guides the principles of stratigraphy. Stratigraphy is the study of the Earth's layers. It tells the era and geographical distribution of strata and study the classification of strata and their relationship between stratas. If we want to know formation sequence of layers on the Earth's crust, there are 5 principles we need to follow. These 5 principles are known as principles of relative dating.
The first, principle of superposition. This principle states that in undisturbed strata, older rocks were deposited first and located on the bottom, with younger strata on the top. Second, principle of original horizontality. This states that as sediments and rock formations are created, gravity keeps them horizontal to the surface. And it suggests that if rocks are tilted or folded, all these events must have occurred after deposition and lithification. The third, principle of cross-cutting. This principle states that all folds, faults, and igneous intrusion are younger than the rock they carved. The fourth, principle of original continuity. We know that sediments are deposited parallel to the surface. Therefore, if horizontal strata are cut by erosional features such as valleys, they can be determined to be the same strata through the similar rock and fossil. And the fifth, principle of faunal succession. Living things will exist and then become extinct at the end within a specific period of time. This principle states that the age of a rock can be known by determining the fossil it contains. However, there are missing time in the rock record. This is called unconformity. An unconformity is a gap in the rock layer where no sediment has been deposited or where the sediment has eroded before the next deposition. The 3 types of unconformities are angular unconformity, disconformity, and nonconformity. Angular unconformity is easy to identify because it occurs when younger rocks deposited on tilted rock layers. Disconformity occurs when old horizontal rock layers are eroded and new rock is deposited on the eroded surface. Nonconformity forms when sediments are deposited on igneous or metamorphic rock and erode over time. It separates sedimentary rock from igneous or metamorphic rocks. Now look at the example here and write down your answer. First, which layer is the youngest? Second, which is the oldest? Third, is the fault older than layer J? Explain why or why not. The fourth, what type of unconformity is it and why?
Aside from relative dating, absolute dating is also an effective way to let people explore ancient times and paleo life. As early as 1907, a scientist first introduced a uranium-lead dating technique to determine the age of geological samples and suggests that the age of the Earth is between 400 million and 2 billion years old. This scientist was Bertram Bolwood, who was born on July 27, 1870 and died on August 15, 1937. He was seen as the pioneer of radiochemistry. Then, what is radiochemistry? It is the study of radioactive elements using chemical techniques, and radioactive decay is an important part of this study. When an unstable element decays, energy will be released by emitting radiation, and it always goes with a loss of particles. Because unstable elements continually decay, scientists can determine the age of a rock based on the element's decay cycle. This is where half-life can be very useful. The half-life of an element shows the time required for one half of the parent isotopes to decay to daughter isotopes. By using the half-life, a relatively accurate age can be known. As scientists continue to study the elements that decay and the characteristics of elemental decay, three main types of decay are used in absolute dating. Alpha decay. In alpha decay, an atomic nucleus will emit an alpha particle, which is a helium nucleus, and thereby transforms into a different atomic nucleus. Beta decay. In beta decay, the proton in the nucleus will be turned into a neutron, which is beta plus decay. If a neutron is converted to a proton, it's known as a beta minus decay. Electron capture. In electron capture, an electron will be captured by a proton. This creates a neutron, emits a neutrino, and releases energy.
After knowing how absolute dating functions, let's have a look at some common examples. Radium-226 decays to radium-222. Radium-226 has a half-life of 1,600 years, as natural radium has a very short half-life. Radium-226 is the disintegration product of uranium-238. However, it can still be used to determine the age of rocks. Carbon-14 decays to nitrogen-14. Carbon-14 has a half-life of 5,730 years, with a dating range of 100 to 70,000 years. Its relatively short half-life means it cannot be chased to a very long time ago. Since all organisms contain carbon, it is used to date fossils, wood, and bone. Uranium-235 decays to thorium-231. It has a half-life of 713 million years, with a dating range of 10 million to 4.6 billion. Uranium-235 is found in most igneous rocks, so it's effective for scientists to determine the age of the rock. Potassium-40 decays to argon-40. It has a half-life of 1.3 billion years, with a dating range of 50,000 to 4.6 billion years. At this point, potassium-40 can be used to determine the age of rock, even it's from the Paleozoic. It can be used to date many kinds of igneous rock. Uranium-238 decays to lead-206. It has a half-life of 4.5 billion years, with a dating range of 10 million to 4.6 billion years. Therefore, it can be chased until the Tertiary period. However, uranium-238 can only be used to date rocks that contain the zircon mineral. Rubidium-87 decays to strontium-87. Its half-life is 47 billion years, and it has a dating range of 10 million to 4.5 billion years. Even though most igneous rocks contain the decay of rubidium, its half-life is too long for the date to be accurate. Now let's have a look at some questions. If there is an igneous rock more than 2 billion years old. Question A. Can we use radium-226 to determine its exact age? Question B. Which method would be the best to determine the age, and why?
Answer A. Since radium-226 is only a disintegration product of uranium-238 and without a clear dating range, it cannot be used to determine the exact age of a 2 billion years old igneous rock. Answer B. According to what we learned, potassium-40 has a wide dating range with a relatively short half-life. Also, it doesn't really have limitations on the substance that the rock should contain. Therefore, the potassium-40 decay method is the best to study this 2 billion years old igneous rock. Overall, this video has identified how relative dating and absolute dating work respectively, and examples are given as well. Then, if you compare the relative dating method and the absolute dating method, which one would you like to use for studying a rock, and why?